Hello, this is Kenny Belfato at SimTech, and today we're going to discuss how to go from a model to machine. Everything you need in step-by-step form to go from 3D models or assemblies into nested parts and programs, labels, reports, individual NC code files, and nested NC code files. Here's our webpage, sim-tech.com, and we've got a great software solution for you. Let's take a look. Here's an AutoCAD drawing, and everything I'm showing you here will also work in Inventor and SolidWorks and Solid Edge. And when you have 3D models in AutoCAD, for example, you can actually name the parts right here. So you can give them part names, and you can put in information for label fields right here. So you could type in a part name, and here's your label field information. Okay, so whatever you put in there, that is a way to attach information right to the 3D solids. It also uses whatever materials you have inside of your AutoCAD material database. So all of that information comes through, and we do what's called feature recognition in just a few steps. There's something called Solid Sim, and I could select solids and put a window around the entire assembly, and it begins the feature recognition process. Now this makes geometry on different layers all automatically for you. So here's a cut list that can be generated. There's a cut list, and that has the name of the parts, their materials. There's that one called end panel right here. And by the way, you could also change the name here as well. Right there. And then there's the different materials from AutoCAD Material Database or Inventor or SolidWorks or Solid Edge Material Database. Also the quantities in there. So there's just one button to export these. There's an export button. It creates what's called the CSV. This is an Excel spreadsheet type of file or a cut list. And it has the name of the part, the material, and the quantity in there. So there's your first column is name, material, quantity, panel dimensions. So these are good if you want to cut them on a saw. We export this and link directly to Artist or CutRite software. And here would be your label information. So you'd have all this information in a cut list. And that cut list, you could just right click on that and pick Cut with Router Sim Automation Suite, and it'll start processing the parts automatically for you. Before I do that, I also wanted to show you here is our explode feature. Or expand, I'm sorry, and you hold the mouse down and you can expand the assembly out to show you guys how to assemble it. And at that point, it's got part numbers on both sides. It could also lay the parts out flat with one click, and there's all the parts laid out, and they have the geometry on different layers for us. This stuff was ignored here because we have some settings that let you ignore things that are smaller than a 1-inch cube, thicker than 2.5, or thinner than 60 thousandths or so. And it'll generate drawings or DXF files or both, and it puts things on different layers. So any holes will be a circle on layer hole. Dados will be a rectangle on layer dado. You could choose your layer names, fully configurable on the layer names. And so, for example, in these models, there is the geometry created layer outside with the depth that you specified. And let's go ahead and make the toolpaths for it now. So it was one click to turn all these individual drawings with geometry on different layers, and one more right click and cut will begin the router sim automation process to generate the toolpaths for us automatically. Here, if a material did not exist, you can add a new material. And here's where you put in your material size, sheet size information, bridge width, how close to put parts together, stay away from the edges, can we rotate, use cross grain or grain rotation, make a scrap cut if there's so many inches left over. We can save the scrap, use the scrap. We also have alternate stock sizes and skeleton cutting available. And now it knows the name of each part, the material, and the quantity. It goes through and makes the toolpaths for us automatically. So we have the software set up to do either code single part or nest parts, or both code single and nest, which is useful for remakes. You'd have the program already available to remake the part. And we're going to get labels. We're going to get G-code checking, so it'll scan your G-codes, make sure that you don't have any Z values that go too deep or any X and Y's that go off the table. There's an automatic G-code scanner. We have fully customizable labels built in the router sim. It'll make all the labeling for us, and you can customize the labels. And then here's the nesting of the different materials. Each one of the different materials nests individually. You could have filler quantities as well. So you have a basic quantity, and you can also have filler quantities so that you don't get any scraps. It makes a scrap cut, so it can save this piece for next time. And it makes a label for the scraps as well. So you can see the cutoff there. You can save that piece of material if you choose to. Fully integrated rolling scrap manager is what we call that. So each of these parts it's got a single program. I've got a nested program, and now I get the final sheets are completing, and we'll have all the labels and the reports built in. So in 2 clicks and just a couple minutes, we've got all the part programs for each one of those sheets. There's all my NC code files ready to run. It saved the PDF file that has the individual parts and the nested sheets. It has all of our individual parts in here, as well as the nested sheets. And you can have this print out to whatever printer you like, and to PDF or to PDF. You could just do print or PDF, any one of them. Here's all the individual drawings with their toolpaths saved in them. Here's all my individual NC code files. So I got 11 individual NC code files, and then this many of the NC code files here, another 8. So we've got 19 programs that were generated, and it saves the drawings of each one of the nests so that you can edit these and drag other parts in there. For example, there's my parts nested, and this is using what's called a tool stay down nest. We've got tool stay down, common line, 2-sided nesting. See, the tool stays down and connects from part to part without lifting up. There's an overlapping bridge, and that can reduce the overall cycle time dramatically. You can also drag and drop parts from another job in here very easily. So I can go and grab parts from another drawing. Let me find some of those. I got some single drawings here, so I can just drag and drop a part from here and put it on my sheet here. So that's an AutoCAD feature that lets you do that. And of course, because we're inside AutoCAD, we can use any of the AutoCAD commands right on parts and toolpaths. So if I want to rotate this one and then move it here, so I'm laying out my own nest, for example. And of course, you could draw your own parts in. Nobody has a better drawing program than AutoCAD. So if you're going to draw in 2D, compare that to any other CAM program that has lines and arcs commands. Okay, AutoCAD does it a little better and easier. Also, if we have ellipses and splines, I like to show those. We'll convert those into arc segments, where a lot of other programs will make a series of little line segments there. So we could take that, even if there's a problem in the drawing, because a lot of times if you get drawings from someone else, they draw sloppy, and there's a little break in the geometry there. So I could load the router sim program, activates the router sim, and then from here, so those other parts were 3D, but I'm going to work on this as a 2D. There's a step that'll take whatever we select and group it together and close it into a continuous shape. You choose where you want your start point to be, and all our toolpath information is right here. So I have what are called machining knowledges. Here's my outside is a 3/8 bit and tool number 1, 1200 inches a minute, go through the material by 3000ths. Or I could plug in a specific depth right there. We could also turn on what's called a corner punch, because this shape has those little notches in it. Now we give you a command called bubble fillet, but you don't even need to use that. The corner punch will send the tool into that corner for us automatically, so you'll get the relief to cut the part. Even though we drew in 2D, you see the tool path show up in 3D. Full control over cutter comp, so you can do tool wear, cutter compensation. Here I'm going to switch it to inside cutting. These are all different machining cycles we offer. Here's like an onion skin, so go almost through and then all the way through. Cut on this ellipse, which by the way is now converted into arcs. So the ellipse and the spline are all arc segments here. They're converted into arcs wherever possible. So that saves you a lot of cycle time as well. So this is 2 passes. It ramps down right along the contour of the shape. RouterSim's the only one making a helical move like that, follows the contour of the shape, gets to the first level, cuts around the part, slides down to the second level, overlaps, leads out, cancels cutter comp. So instead of twice around the part, we can do something where we go, for example, 1.5 times around the part. We do what's called a tab at cut start, and I could put in a decimal percentage there. And when this makes a cut, this leads in and right away makes a tab, cuts around the shape, then the overlap cuts the tab off. So that's 1.5 or 1.4 times around the part is what I put in there. Here's 1.25, for example. I put in 0.25 for this. Cut this one. And again, you can see what's going on. It leads in, leaves a tab, and it's a ramp tab. Ramp up, ramp down, not lift straight up, burn the part in the tool, and plunge straight down. So it's a ramp tab, cuts around, then the overlap cuts the tab off. And so now I've got some shapes in here. And we could take any of these tool paths from other parts and copy them in there. So if I want to take this pocketing, for example, I can copy this, put it on my part here. Okay, so you use any of the AutoCAD commands right on your part. So I copy this piece here. Let's make another one over here. Okay, so here I took the existing nest. I dragged parts from another job, and I drew my own 2D geometry in there. By the way, that corner was fixed within a tolerance. It fixed this for me automatically. Made me a new shape right over top of the old one that has a fixed shape. So it fixes it for you, and you can mix and match 2D and 3D geometry. Here's the RouterSim ready to sequence those, put them in an order. We've got all different sorting methods. You could either pick the order yourself, or I could sort by area. So I do my smallest parts first. I am sort by rank. So I have my pocketing as rank number 1, my inside cuts rank number 2. You can make a rank 1.5 that goes between those. All different sortings. It's going to give me a cycle time report using a kinematic time study. And what that does, it's a very accurate time study, comes up with about 2 minutes cycle time. It adds things like machine-related downtime, handling, personal fatigue, setup. Really going to be about 2.5 minutes. We know what tools were used and how many inches they cut. Even though we did a lot of cutting at 1200, sometimes the tool had to slow down. There's a rapid travels from interior cut to interior cut. And it does all the cycle time analysis there in Excel. And there's the new NC code file for you right there. So that's a RouterSim from an automatic nest, drag and drop other parts, draw my own parts in 2D, sequence them all together, saves it as a DWG file. That was the RouterSim program. The other thing that we got from this was labels. So we got barcoded labels for all this. So you get customizable labels, and you can customize the labels any way you like. And then you also have your, we have a feature in labeling called Touch and Print that could show the picture of the nest, and the operator just shows it. He can see what the parts look like on the screen. He just picks a part and prints it. It'll print a label for you right there. So you have your settings. You could set whatever printer you want to go to. So you could do a touch and print labeling system that's right at the router to print labels. There's a simulation in here too. So any of your tool paths can simulate. It shows the tool removing the material on there. Let me see which one it was. With the larger one here. There it is. You can set the speed. And that's the tool stay down. So the tool is staying down, connecting one part to the other. So that lowers the cycle time for you quite a bit. There's also scrap and skeleton cuts on there. The other information in there is your full reports. So you've got a material usage report that has all your total number of sheets that are used and the different materials and their different stock sizes. All that information is saved for you and it's ready to run at the router. They can go right to the router as well. So I just showed you there from AutoCAD into RouterSim and nesting toolpaths. The other thing we can do it from Inventor or from SolidWorks. Here is the Inventor. So if we grab an assembly from Inventor, again, you've got your part names from Inventor. And as you pick these, you have your material names right here. SW3 is the material name. And we can use the grain rotation from Inventor, or we could emboss a symbol on there that tells the parts what direction to rotate. All right, so you have your Inventor assembly. Again, you've got your SolidSim button right here inside of Inventor. You've got your settings, so you can ignore things smaller than 4-inch cube, for example, right there. And then you pick the SolidSim button, and it does the connection. So it takes the model from Inventor or SolidWorks or Solid Edge and runs through the entire process for you to give you the individual drawing. So far I'm one click into this. We really focus on reducing the total number of clicks for you so that you'll be able to process things that you can, for example, right click on any spreadsheet and cut with RouterSim. And you can have like a list of MDF door sizes and it'll process them automatically. So there's all the part names from Inventor. And there's the cut list that's generated. And so you're done here, but you could do the expand and the lay flat if you like. So here's the expand view. You don't have to do this, but this is great because it shows the operators how to assemble the parts. So you can do these. This is in AutoCAD. You could further move parts around with the AutoCAD commands. Save this to a PDF file, copy and paste into a Word doc. There you can lay all the parts out flat. And here you can see what the feature recognition does on these parts. For example, we've got this panel that has machining on two sides. So up here, it made a pocket cut and it has the depth that you specified and it extends it past the edge of the part. And when it's exported, it'll also have the pocketing on the bottom too. So we could do two-sided nesting. One of the SolidSim settings is what to do with two-sided. Should I make a separate drawing for backside, add this to the name of it, make a separate cut list? If not, we could do what's called two-sided nesting, which puts the sheet on the table upside down, does all the machining on the back side, trims the edge of the sheet, and then does the machining on the front side. So in each one of these cases, those dados and pockets are extended past the edge of the part. So we've got those exported. We can right-click on the cut list and cut with RouterSim Automation Suite. And while it's doing that, I can close out of the Inventor. And again, we're going to get, so really just two clicks. One to make the cut list and the parts, and another click to export those to RouterSim and cut and nest the parts. Very automated, very automatic, 3D assemblies, the toolpaths and nests in just a few clicks. Feel free to give us a call and take a look at the website, the sim-tech.com website. While it's processing those, oh, sorry about that. We've got, while it's processing those, we've got individual programs being generated. There's the nest of our individual materials with scrap cuts. Traditionally with 3D models, you have many other steps to go through, and the router sim will really save you an enormous amount of time when working from 3D models or 2D drawings. The integration inside AutoCAD is a key advantage because every CAM program has CAD-related features like move, copy, erase, zoom in, zoom out. We use the AutoCAD version of those, which is far superior. And then here's your NC code files. Again, everything is done in just a few clicks. The RouterSim automation program is a SQL Server database. And here's those two jobs that we just ran. And I can pick on parts and see them here. You have your different materials. We already looked at the materials. Here inside the parts, you could choose to nest and code single or just nest or code single. You can put in label fields here, full control over grain. You've got filler quantities. We can do veneer match or part matching so the drawers stay together, for example. You can also make a new job and you can have other jobs inside of it. So you can add jobs that go right inside of each other here. So you tell it how many of each you want. I want 3 of these and 2 of those and 4 of these. So you can have a job that has other jobs inside of it. Very powerful way to do full grouping of parts and merge materials together. We've got advanced features like cart control that help you to unload the parts as well. And you can take a job and you can use what's called multi-post. And here it lets you pick different machines that you want to output to. And you can have this one job output to several routers or several NC code controllers, or several controls at once. So if you have multiple machines in your shop, you can have the job output to multiple machines. You've got the full labeling editor, and you've got that automatic G-code scanner that lets you choose, for example, the Z-axis, don't go any deeper than -0.125. So that'll check your G-codes. If any Z's are deeper than that, it's going to alert you and put those NC code files in a check folder. You can have a check X and Y as well, but Z is the most important so you don't crash the machine. We care about your router, and the RouterSim is a great solution for programming, nesting, labeling. We support advanced features like material handling systems, painting heads. For example, the Ontrude has a paint head available, and we support painting on those machines as well. So you can paint text or write on lines, arcs, and circles, geometry right on the screen. So that is the SimTech software, the RouterSim software. Thank you so much for taking a look. Feel free to give us a call anytime if you have any questions.